Euclid's division lemma. Given positive integers a and b, there exist unique whole numbers q and r satisfying a is equal to bq plus r, where r is greater than equal to 0 but less than b. Let us understand this lemma with the help of examples. Example: show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1, where q is some integer. Solution: let a be any positive integer and b is equal to 2. So by Euclid's division lemma, there exist integers q and r such that a is equal to 2q plus r, where r is greater than equal to 0 but less than 2. It implies either r is equal to 0 or 1 because r is an integer. Therefore, a is equal to 2q plus r, or it becomes a is equal to 2q or a is equal to 2q plus 1. If a is equal to 2q, then a is an even integer, as it is a multiple of 2. If a is equal to 2q plus 1, then a is an odd integer. As 2q is even, 2q plus 1 will be odd. Euclid's division algorithm. An algorithm means series of well-defined steps which provides a procedure for solving a type of problem. Or Euclid division algorithm is a technique to compute highest common factor, or HCF, of two given positive integers. HCF of two positive integers a and b is the largest positive integer that divides both a and b. To obtain the HCF of two positive integers a and b, where a is greater than b, follows the steps given below. Step 1. Apply Euclid's division lemma to a and b. We find whole numbers q and r such that a is equal to bq plus r, where r is greater than equal to 0 but less than b. Step 2. If r is equal to 0, b is the HCF of a and b. Step 3. If r is not equal to 0, then apply Euclid's division lemma to b and r. Step 4. Continue the process till the remainder is 0. The divisor at this stage will be the required HCF. Let us understand this lemma with the help of an example. Example: use the Euclid's division algorithm to find the HCF of 867 and 255. Solution. Step 1. 867 is greater than 255. Applying the division lemma to 867 and 255 as shown here, we get 867 is equal to 255 into 3 plus 102. Step 2. Here you can see that the remainder 102 is not equal to 0. According to Euclid's division lemma, r is equal to 102, which is not equal to 0. So again apply the division lemma to the divisor 255 and remainder 102 as shown here, and we get 255 is equal to 102 into 2 plus 51. Step 3. Remainder is 51, which is not equal to 0. So again apply the division lemma to divisor 102 and remainder 51 as shown here, and we get 102 is equal to 51 into 2 plus 0. Now the remainder is 0 and the divisor at this stage is 51. Therefore the HCF of 867 and 255 is equal to 51.